Hello everyone, it's Dr. C. What I would like to do in this video today is continue a limiting reagent problem that we've worked in the past. This limiting reagent problem is in a video that's titled Stoichiometry, Limiting Reagent, and Percent Yield. So let's review that problem very quickly and then continue it and look at how much excess reactant remains after reaction. All right, so here we have 400 grams of propane reacted with 600 grams of O2. How much product is produced? How many moles of CO2 is produced? So the way we work this problem, and it's outlined here, is we looked at each reactant separately. So let's start with propane, C3H8. Okay, so that's the first calculation shown. If all 400 grams of propane were to react, how many moles of CO2 could we get? Okay, so in effect, we're ignoring the O2 at this point. We're just looking at the one reactant. If that were all to react, how much product could we get? All right? And as usual with a stoichiometry problem, we use the molar mass of propane to convert to moles and then apply the mole ratio from the balanced equation to get the moles of product. All right, let's do a second calculation for the other reactant. If all of the O2 reacts, how much product could we get? Same thing, we convert from grams to moles of O2. Now that we have moles of O2, we can apply the mole ratio from the balanced equation to get to moles of product. All right, and clearly the smaller amount of product is the correct answer, the 11.25 moles. All right, the amount of O2 limits how much product we can get. The O2 runs out, reaction stops, and we only get 11.25 moles of CO2. So oxygen is clearly our limiting reactant or limiting reagent. And then the other reactant, in this case propane, must be our excess reactant or excess reagent. All right, so now the second part of this problem is how much propane remains. Okay, how many grams of excess reactant remains? And our excess reactant is propane. So let's look at how we're going to solve this. So let's start with the moles of CO2 from the propane stoichiometry and subtract off the actual moles of CO2 produced. All right. Now, why would we want to do that? Where does that get us? Okay. So we did these two calculations. So this is pretty easy. We can just subtract the smaller amount from the larger amount, and we get this number. So what does this mean? Well, we will never get that extra 15.96 moles of CO2. But we can think of this as the extra CO2 that would have been produced if the excess propane, C3H8, had reacted. So think of about that for a second. We will never get that extra 15.96 moles, that difference. But that is the extra we could have gotten hypothetically if the excess propane had reacted. We can now use that number to work backwards. Okay, we can use that amount of CO2, that excess amount of CO2, the extra amount, work backwards to find the excess propane. Okay, and that's what we're going to do. Let me make one point here before we do that. Sometimes the problem might ask you to go to grams of product, so grams of CO2. You can do the same thing at this point with mass. You could subtract the smaller mass from the larger mass in your two calculations to get grams of extra CO2 and then work backwards from there. Okay, so watch for that. All right. Now, I don't know why I have this little blue box in the corner, but we'll work around that. And so let's take our 15, let's just go back to the other color just to contrast here. Let's take our 15.96 moles of CO2. Remember, propane is our excess. All right, and I'm going to scroll back up just a little so I can see the mole ratio. We want to get back to excess, so let's go back to propane. Has a coefficient of 1. And then CO2, coefficient of 3. There's our mole ratio. Moles of CO2 cancel. And that's going to give us, and let me just write it down here, 5.320 moles of propane in excess. All right? So that's the extra amount of propane left after reaction, the excess amount. All right? Some problems might ask you to stop at moles of excess reactant. We'd be done at this point. But this problem said how many grams of excess remains, so we have one more step. And what is that? Yeah, we use the molar mass to convert from moles to grams. So 5.32 moles of propane. Molar mass, 44.094 grams of propane in 1 mole of propane. Moles cancel. Again, watch your conversion factors so that the appropriate unit cancels and you end up with the unit that you want, in this case grams. And our answer comes out to be 234.6 grams of propane in excess. All right? So there's our final answer. So the question was, how many grams of excess reactant remains after complete reaction? There you go. Now, the last thing I would think about after you finish this problem, and you should do this on as many problems as you can when you do the calculation, is at least ask yourself, does my answer make sense? All right? So let's go way back to the top of the page and look at what we started with. We started with 400 grams of propane. Some of that reacted. So certainly we should have less left over than what we started with, which is what we have, 234.6. So that seems reasonable. As an example, if we did this calculation and we ended up with more left over than what we started with, clearly we would have made a mistake in our problem and we would need to go back and check our work. So always at the end of a problem, if you can, say, does my answer make sense? Or using baseball terminology, is it in the right ballpark? Okay, so estimating and at least checking your work at the end is always a good idea. All right, that's all for this video. Have a wonderful day. Take care.